because I've been having so much trouble with reading, I decided that I'm going to make this video, and hopefully this helps everybody understand the quiz a little bit better in case you wanted to submit your review without waiting for feedback, um, or the response to the review questions without waiting for direct feedback. So I am going to be working more on feedback as well. It is a little bit harder for me to do during the week than I anticipated just because I read so much throughout the day. So I have created this document, and I'm hoping that it will be helpful for you all. We're going to go over it in this video first. Um, but I suggest that you download this. You can take notes on it. It could be a guide for you. You can keep adding to it the rest of the semester, and maybe even possibly use this as something that could help you study when it comes to the final exam. So we're going to go over each of these topics, um, not necessarily in depth, but we'll go over these topics to discuss kind of what I'm expecting from you um, when it comes to your final and what you should know by the end of this course. Okay, or not necessarily by the end, but you should at least have a good understanding of now. If you don't, this is good review. You may not have a great understanding of everything, and that's fine. Um, it's not going to come easy, and it's just going to take time for everyone. This is not a course that it's likely that everybody will get an A in. It's just difficult. So these are difficult topics. It's okay. Um, Nobody's expecting perfection out of any of you, okay? So let's go over this, and if you have questions, then you can send me messages about that. But we'll talk about that a little bit more as well. So first of all, when we consider stats, we need to know descriptives and visualizations of data. So as far as basic uh, descriptives, we need mean, median, mode. Those are central tendency. So mean is the average, median is middle, and mode is most frequent. If you're looking at categories, mode is going to be very helpful for you. If you have data that has um, outliers or just a big variation, for example, income levels. So if you have something like that, median is really helpful. Um, and then mean is the average. So mean is really affected by outliers. You need to know and understand that. Um, so if you have outliers, you do need to consider, okay, if I can't remove these, I need other measures of central tendency to pick those out for me and um, give me a little bit more of an idea of what the data shows. So we also have measures of variability, standard deviation. That's just the average deviation from the mean. In regard to like all the variation, we have variance. That includes all the variation between these numbers in your data. And if you're looking at average, that's the standard deviation, it's the average deviation from the mean. Range, that's going to be top and bottom, like either the distance between those or just listing it as a range of, say, 1 to 10, or just the lowest number that you have and the highest number. Oh, excuse me. And then we have frequency distributions. That's just going to show you frequency of something. So if you consider categorical variables, so if you have males and females and you want to know the frequency, you could do a bar graph. However, if you have a data set that is all numeric, that may be something that you um, use a histogram for. So you you have to figure out, okay, what kind of graph do I need? If you're looking for outliers, you need to use a box plot. And as far as a scatter plot, that's a relationship. We haven't gotten to that just yet. We will be getting to that um, this coming week. So, scatter plots for relationship. We haven't discussed relationships yet, so it's important that you understand that when you say relationship, that's correlation. We haven't gotten to that yet. Skew and reading skew on a graph. You do need to understand what skew means. It is kind of difficult to remember um, which skew is positive and which is negative. You just have to remember the skew is where the tail is, so where it trails off. So it's not necessarily going to be just because something trails off a little bit, you can't say it really that it's skewed either. But it is where the tail is. So if the tail trails off to the left, it's a negative skew. If it trails off to the right, it's a positive skew. It's not where the data stacks up. That's different. It's going to be opposite of that. So you have to remember that and just know how to read that on a graph. Know how to read box plots, scatter plots when they come up and such. Same thing with kurtosis. So kurtosis is just basically a very, very narrow range of data that's very stacked in the very middle. So you have to remember what skew is, what kurtosis is, what those numbers are. If I gave you numbers, you should be able to tell me if they are considered problematic. And if we remember in other videos I mentioned, plus or minus 2 is a good guideline to go by. So if the numbers fall within that range, you shouldn't have to worry about it. Now, as far as the importance of checking assumptions. Okay, so we all remember checking assumptions as we go, right? For this course, you've had to do that several times. And you know that there are assumptions to each of these parametric statistics. We're not doing non-parametric statistics in this course, so these are considered what we call parametric statistics. So they will have assumptions, and the assumptions are important because if you do not if you violate these assumptions, this may not be an appropriate test to use for your data. That's really important to know because these tests that we are using rely on these assumptions. So in order for the findings to be accurate, we need to make sure the assumptions are not violated. Now, you will have read in the chapters that sometimes the assumptions or certain assumptions may not be as problematic if they're violated, and that's fine. But if you do find a violation, you have to report it, and you don't necessarily see people in statistical sections of articles where they talk about checking assumptions. And that's also problematic because we don't know that they actually checked assumptions. And so if we see them running parametric statistics and they are not checking assumptions, that's a problem, right? Not that they didn't, but they didn't report it. And one of the basic principles we have of research is that you need to report everything you do. In order for us to replicate studies we need to have everything reported so we know how to design this study, right? We have to have everything. So if it's not in there, then you don't know whether it was done or not. You don't know whether the article is trustworthy. It's just very, very difficult to maneuver around, right? You're not going to find it in every article. It's just not going to be there. That doesn't necessarily mean that the information is bad. It does. It is a red flag, so you have to be careful of that. But if you're doing research on a topic and you are gathering all these um, journal articles to do so, even if it's just a research paper, you want to try to get the most reliable research, not the research that confirms your hypothesis. You need to get the most reliable research that is trustworthy. So there are predatory journals out there. These predatory journals um, will publish pretty much anything if you pay them. So there are plenty of those out there. I can assure you there are plenty. And sometimes they will actually send you emails to try to get you to publish and pay them to publish. So, and getting publications on your curriculum vitae is really important as a researcher because that's how you get tenure, that's how you get higher pay. Um, so there's going to be people who do some shady things to get published. But it's important to remember that there are indicators of good quality research, and one of them is making sure the assumptions are checked. So we need to check assumptions as we do these stats, and we need to make sure other people are doing that as well, and at least reporting it if there are, if the assumptions are violated or not. They may not need to necessarily go into the detail that we do in our write ups, but um, just mentioning the assumptions were checked with no violations is really important. Um, so you need to understand why that's important, okay? So these tests rely on those assumptions, and if they aren't met, we might have an issue with the test type, right? Okay, so you also, as I mentioned about reading journal articles, you also need to be able to go into a journal article that you are gathering for some other class and look over the stats and be able to kind of understand a little bit more about what's going on. You're not going to know everything because these stats that we're learning are basic level, and most of the stats you see in research journals are probably going to be higher level. Um, Lately anyway, but you should be able to at least kind of get a feel for what they're doing, right? So you may not understand what structural equation modeling is, but you understand basic stats. So just being able to go in and make sure that they're doing the things that they're supposed to be doing, and make sure that the p-value is 0.05 or less if they're saying there's significance, because you will see people say um, marginal significance. You'll see, and I think it even mentioned that in your textbook. And some people aren't as worried about it, whereas others are. Right now, 0.05, that is the generally accepted value. Um, but people do report things as, oh, it was approaching significance. I wouldn't go by those. It is one of those things where if they'd had more people, yeah, maybe it would have gotten to the level they needed, but we have to have boundaries that we set. So we need to maintain that research integrity and, um, really dig in and try to do what we're supposed to in research so we have good quality work. Now, when you're talking about type 1 and type 2 errors, you need to be able to explain what those are. I have created this little um, diagram here, this little chart here for you. So basically we have, okay, we have the null hypothesis. Is it false? Is it true? And did you reject it? Yes or no? Okay. So if the null hypothesis, which is nothing is happening. If it's actually false and something's actually happening, but you don't reject the null, then that's a miss, right? Because something is happening, but you're not rejecting the null. So you missed something there. Now, if the null hypothesis is false, but you do reject the null, that's a correct statement, right? I rejected the null and the null was false. So you made the right move here. Now, as far as if the null is true, nothing is actually happening, and you fail to reject, then you're correct again. So that's a good situation. Both of these are good situations. But if nothing is actually happening and then you did reject the null, that's considered a false alarm. So you're saying something's going on when nothing's going on. So if I give you situations like this, if I say I reject the null and the null was true, then you should be able to say that's a type 1 error. And remember, um, p-values, like getting it to the low level, that's because we want to make sure that we're not making a type 1 error. Okay. So you also need to be able to choose the proper type of statistic in a study situation. So you should be able to, if I say design a study where you're using an independent samples t-test, you need to be able to design a study around an independent samples t-test. Just like a general study where you tell me what you're trying to, what your hypothesis is, what the variables are, and so on. You also need to be able to do the same thing except backwards. So if I give you a study, like I give you the information about the study, you should be able to say, oh, this type of test should be used in that situation. So both of those are equally important. So please practice that. You should know these things for your final exam. Now, when you think about what tests to use, like right now, this is what we've covered. So, well, we've also covered one sample t-test. That is more like if you have a number that you're comparing to already. Like the typical exam score is going to be, what, 75%? That's a C. That's an average score. That's a supposed average score. So if I'm comparing the results to some expected population average, then I only really have one sample. I'm not really comparing to another sample. I'm just comparing to existing value. Okay. Now, otherwise, you have to think of, okay, do I need inferential or descriptive statistics based on these questions? So if it's a hypothesis and you have to test this hypothesis, then you're doing inferential statistics. What type of question are you asking? Now, we haven't gotten into relationships or prediction, like predictive models or anything like that, like regressions or correlations. We haven't discussed those yet, but those are types you need to understand for the final. As far as differences go, we have discussed that. So, then how many groups do you have? 1, 2, 3, or more? How many variables? What types of variables are they? And is this within or between subjects' designs? So let's consider looking at between subjects' designs. If I make each of these, I'll light each of these up with red. So these three types of tests are between subjects' designs. So you have the independent samples t-test, the one-way ANOVA, factorial ANOVA. They're comparing groups that are only providing one observation. So independent samples t-test might be comparing males and females, whereas you have a within subjects design with a paired samples t-test that is going to be comparing the student to themselves based on like different ratings of things, or a pre-test and post-test, or um, before and after blood pressure when you have something scary in the middle and such. It's not necessarily time dependent. It's just that is an easy way to think about it. So that's a within subjects design, and the same thing with a repeated measures ANOVA. So the different types of ANOVAs we have. Repeated measures is going to be the before and after situations, um, such as the ones I just mentioned for the paired samples t-test, except you have more groups to compare. Okay, so really important to remember which tests to use, what types of designs they are. Um, so independent samples t-test, for example, has two groups, um, one outcome variable. The IV is categorical and the DV is continuous. So males, females, categorical, IV, and then on some sort of score. So test score might be something that we use there. And all these are continuous and all these are categorical. So I'm going to use a similar example for each. Now this paired samples t-test, rather than males and females here, it might be the student's before and after score. So this is the IVs before and after, and the DV is still the same score. Okay. One way ANOVA, we have three different groups. So we might do um, if you had a study guide, if you did not have a study guide, and if you had a study guide and a video. So those are the three groups. You were in one of those groups, and then the outcome is again exam score. Now, moving on to factorial, this is you have more groups as well, except this time you're going to have more than one of these grouping variables, right? So you have male, female, and which group were they in as far as like the study guide. So you have males that were in the a study guide group or not study guide group. Females, study guide group, not study guide group. So you're thinking about how many combinations of groups do we have. So we have males in this group, females in this group, males not in this group, females not in this group. So that's 4 different groups to compare. And again, still exam score is going to be your variable, your outcome variable, and that one's continuous. But the grouping variable here, there were 2 different grouping variables, which I will put 2. And then a repeated measures ANOVA. This one is within subjects, so it's like the paired samples. They're providing more than one observation, except again different groups. And then it's like a one-way ANOVA, except it's the within subjects version. Okay, so there are different tests to use in different situations that you need to know. Moving on, if you want to explain what an interaction is compared to main effects. Now, this was probably the most confused question on the review, so I want to kind of clarify that a little bit too. So let's say I have a situation where I'm doing a study where you have anxiety and trying to see if drug or therapy helped anxiety or if there was an interaction between them. So you're going to end up with 4 groups. So again, this will be a factorial design. You're going to end up with 4 groups here, and you have there was no drug, no therapy group, then taking the drug with no therapy, then no drug with therapy, and then drug and therapy together. Now, let's say the drug had an effect on anxiety that you could see by itself, okay, with even controlling for all these other things. The drug had an effect on anxiety, okay? That's a main effect. Um, there's a main effect of those things, or of drug by itself, and now, is there a main effect of therapy by itself? Let's say no, there wasn't. There wasn't a main effect of therapy, so it didn't show any difference there. So you're saying no, therapy itself didn't do anything. However, when you look at the interaction between them, that was statistically significant, which means that controlling for everything else, when you combine drug and therapy, they impacted anxiety more above and beyond what drug did by itself, okay? What therapy did by itself, which therapy didn't have an effect by itself, but when pairing it with the drug. So in this case, it might be that, okay, therapy didn't help, but it was because the person wasn't open to therapy, wasn't just their brain chemistry was off, so their mood would not allow them to accept therapy as a solution here. But when you gave them this drug, like Paxil or something like that, they were more open to therapy, so therefore therapy helped, but it did not help without it. So that would be a situation where there was an interaction. So in order for therapy to have made any kind of impact, it had to be included with the drug. So I hope that makes sense about the difference between main effect and interactions. A lot of people were putting that it was the very independent variables impacting each other, and in a way, that makes sense, but that's not exactly what it is. So you have to have the factors that this is above and beyond what the main effects do, as well as these things together impacted the dependent variable, which was the outcome. So these things together showed a reduction in anxiety above and beyond what the drug did alone. Okay. You also need to be able to explain the meaning of a p-value in terms of probabilities. Let me add that here. In terms of probability. So a p-value is a probability that you have found these findings basically by chance. Okay, so go back, read about p-values, and kind of get that understanding about how, in terms of probability, what this p-value is saying. Also be prepared to explain why you need a post hoc tests, or when. So when and why do you need to use a post hoc test, and explain a Bonferroni correction and the problems with multiple testing. So when I say that, I mean, why would it be problematic to run just a bunch of t-tests instead of an ANOVA? So that's important. And why do we have to do a Bonferroni correction when we do post hoc tests? That we did in that factorial ANOVA. You need to be prepared to talk about effect size Um, so, as we've talked about, as we've discussed, the process of hypothesis testing, you have to check, state your hypotheses, check your assumptions, run your descriptive, make sure you have your descriptive statistics to check those assumptions. You also need to run your tests, and if there's a p-value that's statistically significant, that is when you would have to consider, okay, so in terms of t-tests, you only have the two groups. You don't need a post hoc test because you can tell the difference right away by looking at the means. You can see where the difference is. So you immediately just run an effect size. However, for an ANOVA, if you have um, an ANOVA and you run and it's statistically significant, you have to be able to tell where the difference is. Using a post hoc test would do that. And you have to use a Bonferroni correction, doing the post hoc test the way we did before with the multiple t-tests, because if you don't correct, then you run the possibility of a type 1 error. Because multiple testing, you're going to find something, and there just may not be something there. So that would be a false alarm. And that is it right now for the review. If you have any questions, please let me know. I hope this was helpful, and I will talk to you guys soon.